The Earth's poles, the North and South Poles, are some of the most fascinating and extreme regions on our planet. These icy frontiers serve as critical components of Earth's climate, ecosystems, and even the delicate balance of life. To understand the poles is to gain insight into the mechanics of our planet, the cycles that drive weather and climate, and the adaptability of life in the face of harsh conditions. The poles are defined as the points where Earth's axis of rotation intersects the planet's surface. The North Pole lies in the middle of the Arctic Ocean, surrounded by landmasses like North America, Europe, and Asia. Unlike its southern counterpart, the Arctic is not a landmass but rather a sea covered in drifting ice. The South Pole, located on the Antarctic continent, is a landmass covered by a thick sheet of ice that has built up over millions of years. Together, these poles form bookends to Earth's vast geography, and their differences in geography, climate, and biology tell the story of their unique roles in shaping the planet. The science of Earth's poles begins with their extreme climates. The poles are cold because they receive less direct sunlight than other parts of the world. Sunlight strikes the poles at a low angle, spreading its energy over a larger surface area, which limits the heat absorbed. Additionally, during polar winters, the sun doesn't rise at all, plunging the regions into months of darkness and bone-chilling temperatures. At the South Pole, temperatures can plummet to as low as -80 degrees Celsius, -112 degrees Fahrenheit, while the North Pole, tempered slightly by the surrounding ocean, experiences winter lows around -40 degrees Celsius, -40 degrees Fahrenheit. Another key factor in polar cold is the high reflectivity of ice and snow, known as albedo. These surfaces reflect most of the sun's energy back into space, further cooling the regions. This phenomenon plays a crucial role in regulating Earth's overall temperature. If polar ice melts, darker ocean water or land is exposed, absorbing more sunlight and accelerating warming, a feedback loop that has profound implications for global climate. The ice itself is a defining feature of the poles. In Antarctica, the ice sheet contains around 70% of Earth's freshwater, making it the largest reservoir of frozen water on the planet. The thickness of Antarctic ice can reach up to 4 kilometers, 2.5 miles. And its weight has compressed the underlying rock, creating a landscape of valleys and ridges hidden beneath. The Arctic, on the other hand, is characterized by sea ice that forms and melts with the seasons, creating a dynamic and ever-changing environment. Scientists study polar ice to uncover clues about Earth's past. Ice cores drilled from deep within the Antarctic ice sheet contain tiny bubbles of ancient air, providing a snapshot of atmospheric conditions going back hundreds of thousands of years. These records reveal the history of greenhouse gases like carbon dioxide and methane, helping researchers understand how human activities are influencing the climate. The poles also play a vital role in driving global ocean currents, which regulate temperatures across the planet. In the Arctic, cold, dense water sinks and flows southward, creating a conveyor belt of ocean circulation known as thermohaline circulation. This system moves heat from the equator to higher latitudes, influencing weather patterns and ecosystems. Similarly, the Southern Ocean surrounding Antarctica connects the world's major oceans, circulating nutrients and heat that sustain marine life. Life at the poles is a testament to nature's resilience and adaptability. Despite the extreme cold, months of darkness, and scarcity of resources, a wide range of organisms has evolved to thrive in these environments. In the Arctic, polar bears roam the sea ice, hunting seals and relying on thick fur and a layer of fat to insulate them against the cold. The South Pole, while devoid of polar bears, is home to penguins, including the iconic emperor penguin. These birds endure brutal Antarctic winters by huddling together in large groups, conserving warmth and sharing body heat. Beneath the ice, polar oceans teem with life. In the Arctic, phytoplankton blooms during the summer months when sunlight returns, supporting a food chain that includes krill, fish, seals, and whales. Antarctic waters are similarly rich in krill, which form the foundation of an ecosystem that includes seals, penguins, and the massive blue whale, the largest animal on Earth. The poles are also vital indicators of climate change. Rising global temperatures are causing polar ice to melt at an unprecedented rate, leading to sea level rise and disruptions to ecosystems. In the Arctic, the extent of summer sea ice has declined sharply over recent decades, threatening species like polar bears that depend on ice for hunting. Antarctica's ice shelves, which hold back massive glaciers, are also retreating, raising concerns about the stability of the ice sheet and its potential contribution to sea level rise. The impact of polar melting extends far beyond the poles. As ice melts, the added freshwater disrupts ocean currents, potentially altering weather patterns and intensifying storms. Melting ice also contributes to a feedback loop of warming. As darker surfaces absorb more heat, these changes underscore the interconnectedness of Earth's systems and highlight the urgent need to address climate change. The poles are not only natural laboratories for studying climate but also sources of wonder and inspiration. Their stark beauty, with vast expanses of white ice and shimmering auroras dancing in the sky, has captivated explorers and scientists alike. Early expeditions to the poles were fraught with danger, as intrepid adventurers braved treacherous conditions to map these uncharted territories. Today, scientific research stations like Antarctica's McMurdo Station and the Arctic's Barrow Observatory continue the legacy of exploration, advancing our understanding of these critical regions. The poles are also a source of cultural significance for indigenous peoples like the Inuit, who have lived in harmony with the Arctic environment for thousands of years. Their knowledge of the land, ice, and wildlife provides valuable insights into the changes occurring in polar regions and highlights the importance of preserving these ecosystems for future generations. Preservation efforts are essential to protect the poles and their unique environments. International agreements like the Antarctic Treaty, which prohibits military activity and promotes scientific cooperation, serve as models for global collaboration. In the Arctic, nations are working together to address issues like overfishing, shipping, and oil exploration, balancing economic interests with environmental protection. As we learn more about the poles, we are reminded of their profound influence on our planet. They are not just distant, icy regions but integral parts of Earth's climate, ecosystems, and history. Their fragility in the face of climate change is a call to action, a reminder that the choices we make today will shape the future of these remarkable regions and the planet as a whole. The science of Earth's poles is a story of extremes, adaptation, and interconnectedness. It is a story that unfolds across vast icy landscapes and beneath frigid oceans, where life persists against all odds. As we continue to explore and understand these regions, we gain a deeper appreciation for the intricate workings of our planet and the delicate balance that sustains life.